Let's see how you guys did on this homework assignment. For problems 1, 3, 5, and 7, we were answering the same three parts. A, determine when the particle is moving to the right, to the left, and stopped. B, find the particle's displacement for the given time interval. And C, find the total distance traveled by the particle. So for 1, our velocity was given to us at 5 cosine t from 0 to 2 pi. So first we want to set 5 cosine t equal to 0. Divide by 5. So cosine t is going to equal 0 from the interval of 0 to 2 pi when t is pi over 2 or 3 pi over 2. So then I went ahead and made a velocity number line, plotted the two critical numbers as well as the endpoint. So we know cosine is positive in the first quadrant, so between 0 and pi over 2, and then in the fourth quadrant as well, so between 3 pi over 2 and 2 pi. And then from pi over 2 to 3 pi over 2, those are quadrants 2 and 3, so cosine is negative. So we can answer right away, sort of in a different order, that our particle is stopped when t is pi over 2, 3 pi over 2, really seconds, because at the very top it says v at t is the velocity in meters per second, so time is seconds. Even though for the moving right, moving left, I didn't write out seconds as the label here, but it's you can indicate this either with inequalities or interval notation. After this problem, I just kept using interval notation. It was a little bit quicker to write. So moving to the right, we're going to include the 0 and the 2 pi. So between 0 and pi over 2, moving to the right, equal to 0, just less than the pi over 2. And then when t is between 3 pi over 2 and 2, but including the 2, or interval notation, is listed right here. Moving to the left, just between pi over 2 and 3 pi over 2. All right, for displacement, that's just one integral every single time because we're just trying to see the net change. So if our number comes out to be positive, that means we ended, in this case, we ended up to the right of where we started, or if it's negative, we ended up to the left of where the particle ended up to the left of where it started. Or sometimes these just turn out to be 0. So displacement is just the integral from 0 to 2 pi. So writing this out, the antiderivative here is just going to be 5 sine t, and then t is 0 to 2 pi, so we say 5 sine 2 pi minus 5 sine 0 just gives us 0 meters altogether, so this particle ended up right where it began. Now for the total distance traveled, this is where we need to go back up to this number line. So however many sections we have here, that's how many integrals we're going to have. And any section that we're moving to the left, we have to subtract it because it's moving backwards. Or we take the absolute value of it, because even though we're moving to the left, we still count that. So distance is always positive, so we subtract a negative or an integral that's going to turn out to be negative. So you could look at all the parts here. I'm not going to go over every single step, but just notice that we subtracted the middle integral here. Taking the antiderivative, just watch your signs very carefully. So for these, I highly recommend writing out every single step. But you could pause the video and work through this. Again, if you have any questions on any particular part, send me an email. But this turns out to be a total of 20 meters. All right, for number 3, didn't know that could change colors. All right, so we're given v of t is equal to 49 minus 9.8 t between 0 and 10 inclusive, so just the same first step, moving to the right, left, and stopped. So v of t is equal to 0 when t is equal to 5, so we only have one critical number. If you just picked, for instance, a 1, I know 49 minus 9.8 times 1 is still positive, but if you try a 6, and yes, on these you can use a calculator to help you with the tougher calculations here, but we do get a negative value. So the particle is stopped at t equals 5 seconds, moving to the right from 0 to 5, we're including the 0, moving to the left from 5 to 10, we include the 10. The displacement is going to be the integral from 0 to 10 of the velocity function. So just taking the antiderivative, we get 49t, and then this first was minus 9.8 t squared over 2, so 9.8 divided by 2 is 4.9, and then just evaluating at t equals 10, we'll get 490 minus 490, then minus the 0, really 0 minus 0. So another displacement where the particle ended up exactly where it began. Now the total distance traveled, we have two sections to our number line. The first part of the trip from 0 to 5 is positive, so we're going to be subtracting the second part. So we set up two integrals, 0 to 5 and then 5 to 10, but we subtract this. So again, take a look at each part. You could use a calculator to help you out with this, but the final answer here should be a total distance traveled of 245 meters. So what this is really saying is 122.5 meters to the right and then 122.5 meters to the left. All right, for 5, we have a little bit of work involved. The integral did require some u substitution. So here we are setting our velocity equal to 0. And this is where we could just separate it, just the zero products property. We know if we multiply two things together, two factors together, and they equal 0, either one equals 0 or the other or both. So here, if I separated this 5 sine square of t, if that were to equal 0, divide by 5, which is still 0, take the square root, still 0. So that's going to happen when t is 0, pi, or 2 pi. Yes, technically 0 and 2 pi are the same location on the unit circle, but we still need to list them. And then cosine t is going to equal 0 when t is pi over 2 or 3 pi over 2. So I have all these sections right here. And again, just understanding when sine is positive or negative, cosine is positive or negative could be a quicker way to write out the signs here. So hopefully you're coming up with the same. So I have it listed. Our particle is stopped at time t equals 0, pi over 2 pi, 3 pi over 2, and then 2 pi seconds. We are moving to the right from 0 to pi over 2 and 3 pi to 2 pi, including the 0 and the 2 pi. Now, with the left, I did separate this here. It's not consistent because our particle is stopped. So when it's stopped, it's not moving anywhere. So that's why I sort of broke it up here at the pi. But when we go to write the integral, we can just go straight from pi over 2 to 3 pi over 2 for part C. All right, so the displacement, we're going to need to use u substitution here. So I'm going to let the part that has more stuff in it is the sine squared t. So I'm going to let u equal that. And then when we go to take the du over dt, that's going to equal cosine t. So that's what's going to help us get rid of the extra cosine t. So then du over cosine t is equal to dt. Now I do want to change the limits of integration here. So when t is 0, u is 0. Then also when t is 2 pi, u is 0. So that works out nice. I really don't need to do any work here because these two numbers match. So it's 0 meters. But to go a little bit further, because it is going to help us with the next part, I just want to show you, and I didn't give any limits here, I'm not going to write a plus c, I just wanted to show you what the antiderivative of this was. So using the u substitution, I get 5u squared, because again that's going in for sine squared t, and u is sine t, times cosine t times du over cosine t. So then the cosine t's divide out, and we're left with 5u squared, the integral of 5u squared du. The antiderivative of this becomes 5u cubed over 3, but now I need to bring back the sign, especially when we go to use it in part C. So now this is 5 times sine t cubed over 3. So now in part C, when I go to write out the total distance traveled, remember I had those 3 sections, so I'm subtracting the middle section here. And yes, it takes a lot of work to try to write this out. If this were a test or a quiz question, I would absolutely let you guys use a calculator on it. But looking here, we have, it's going to become the 5 sine cubed t, or 5 sine t cubed over 3. So I just wrote it as 5/3 sine t cubed. And then the first is from 0 to pi over 2 minus 5/3 sine t cubed, 3 pi over 2, and pi over 2. Notice I have the whole thing in parentheses, and then I have the third part. So carefully going through, pause the video, look at each step. I try to write everything out in full detail. Again, let me know if you have any questions, but this one should be coming out to 20/3 meters as the total distance traveled. All right, number 7 is very similar. So here we look at the velocity, set it equal to 0. So if we separated it, again, the zero products property, 0 is equal to e to the sine t. Well, it's an exponential function, so it's never going to be 0. But again, if cosine t is equal to 0, we're coming up with pi over 2 and 3 pi over 2. Making our number line, we see we have 3 sections. So when we get to part C, we're going to have 3 different integrals. We'll be subtracting the one in the middle. So our particle is stopped at t equals pi over 2, 3 pi over 2 seconds, moving to the right from 0 to pi over 2, 3 pi over 2 to 2 pi, including the 0 and 2 pi, moving to the left in between pi over 2 and 3 pi over 2. So our displacement, remember, is always going to be one integral. It's just the net change, and just coincidentally, they all turned out to somehow be 0 meters here. So again, I'm going to let u equal sine t. That way du over dt is cosine t, and our cosine t's eventually divide out by this last part. Again, when t is 0, u is 0, and when t is 2 pi, u is 0. So again, we get the same limits of integration, which allows us to go to 0 meters. But I just want to show you, if I were to write this out or take the antiderivative, the cosine t's divide out, and we're just left with e to the u. Well, the derivative of e to the u is e to the u, so the antiderivative is going to be the same, which still we could just leave as the integral of e to the sine t, so the antiderivative is also going to be e to the sine t. All right, so here's our three integrals. Notice how much work was involved with this one, only again because I showed every step. So pause the video, please look over each part. At the very end, you could leave it in the exact form. I just also calculated the approximation. So again, let me know if you have any questions with part C. Number 9 was a little different. It gave us an acceleration that a car accelerates from rest at 1 plus 3 radical t miles per hour per second. So we have a little bit of work to do with this problem, but that's for part B. So question A is, what is its velocity after 9 seconds? So the velocity is the antiderivative of acceleration. So I'm just replacing A of t here with 1 plus 3 times t to the 1/2. So taking the antiderivative here, we get t plus, we have to be careful with this fraction. So 1/2 plus 2/2 will give us 3/2. We divide by 3/2. And then we still need the constant of integration. So multiplying 3 by the reciprocal of this denominator will just leave us with 2. So we get t plus 2t to the 3/2 plus c. Because the car is accelerating from rest, the initial condition, the initial velocity is 0. That means if we were to substitute in a 0 here, and it would equal 0, c would equal 0. So the velocity function is t plus 2t to the 3/2, and then we can evaluate that velocity function at 63, or at 9, and we get 63 miles per hour in this case. Now for part B, it's asking for the total distance traveled, but we need to be in the same unit. So our first job is to take this velocity function, which is in miles per hour, and we need to go to seconds because we want everything to be, we have to figure this out for 9 seconds, so we need to convert miles per hour to miles per second, or I just wrote it like this. So I'm taking this quantity in miles per hour, and I'm just saying, well, in 1 hour there's 3,600 seconds. So I just separate this. So I first get t over 3,600, and then the 2 and the 3,600 simplify to just t to the 3/2 over 1,800. So what I did to make sure I didn't have a number line for the velocity function here, I went ahead and set the velocity function equal to 0 and realized that t is either going to equal 0 or the other part, the other quantity here, I get 2 times a positive square root, which can never equal a -1. So I have no need to show a different or more than one integral. So I just set this up from 0 to 9. I want to take the antiderivative here. I'll walk you through the first couple steps. So this will become, think of this as like 1 over 3,600 times t. So it becomes t squared over 3,600 times 2. If I take 3/2 and add 1 whole to it, I'll get 5/2. So it's over 1,800 times 5/2. And then we get these two fractions here, again evaluating from 0 to 9. Now what I did is, just to get this last number, I did use a calculator, so you guys could use that too. And then if you simplify this, you're going to end up getting miles, but then you can multiply that by 5,280 and also get it in terms of feet. So either answer is correct, even leaving this as a fraction, but we still like to know what that turns into. So even showing this decimal of a mile, it makes the most sense. We could picture it better if we're just looking at this in terms of feet. So as always, guys, let me know if you had any questions as you were looking this over.